Hi, welcome to my presentation. I wanted to thank Sophia from AWS Startup Accounts for the invitation, and Matthew Rowlands for their support and ideas. My name is Luke Shaughnessy. I am the Operations and Platform Team Manager at Fraugster. We're a fine tech company here in Berlin. I've been here in Berlin for 2 years. I was recruited by the company. I moved here from Colorado with my family. We've been here just 2 years, actually, as of tomorrow. So it's kind of our anniversary. The presentation today is going to be about PCI compliance. So fasten your seatbelts. It's going to be an exciting ride. How I learned to stop worrying and love PCI compliance. If you don't get the reference, this is drawn from a classic 1960s movie from Stanley Kubrick called Dr. Strangelove, or How I Learned to Stop Worrying and Love the Bomb, which actually is a movie about nuclear war, which is really one of the only things that's actually worse than PCI compliance. So I wanted to get into the agenda a little bit on what we're going to talk about today. So first, tiny bit about Fraugster, a little bit about PCI compliance and what this means. Our solution to PCI compliance, which was to come up with a tokenizer, and we'll get into that in a minute. What our PCI zone is, what our technology stack looks like, and how this led to our greater adoption of cloud technology based upon the strength of our success with our tokenizer product. And then a little bit more about the future and what we'll be working on after that. So about Fraugster. Right, so this is taken from the website here. It probably does a better job of explaining it than I could. Our powerful Fraugster engine runs self-learning algorithms that mimic the thought processes of human analysts combined with machine scalability. So in other words, we process credit cards, and we have a real-time engine that processes card swipes and will, within 100 milliseconds or less, declare whether or not we believe that card swipe is a valid or a fraudulent transaction. And what does this mean? This means that we need to deal with PANs. And no, I don't mean frying pans. I mean credit card numbers. That is the technical term for a credit card number. The number that you see embossed on the front of the credit card is actually referred to in the biz as a PAN. Which is a term you hear an awful lot when you start getting into compliance issues, and PCI in particular. So PCI, what is this? PCI DSS compliance. Anytime you deal with credit card numbers, you have to deal with the PCI DSS security standard. This means you have to comply with a whole bunch of stuff. What does PCI actually mean? I have a note here for this. It's a set of security standards designed to ensure that all companies that accept, process, store, or transmit credit card information maintain a secure environment. The Payment Card Industry Security Standards Council was launched in September 7, 2006 to manage ongoing evaluation of payment card industry security standards. So rules, we've got lots and lots and lots of rules. So this is an overview of the rules. This is a start. This is a beginning. We've got a lot of things that look relatively familiar to you if you've ever had to deal with security issues in a data center. You have firewall configuration. We have security parameters that don't use default configurations. We've got to protect the data naturally. We've got to track and monitor access to the network and data. None of this stuff is especially shocking, but it goes into a level of complexity and depth that you might not have encountered before. In fact, this is page 1, PCI requirement. Requirement 1 installs and maintains firewall configuration to protect cardholder data. Oh, it continues. Requirement 2, do not use vendor-supplied defaults, system passwords, information combined with hacker tools that show the devices are on your network. Oh, some more. Requirement 3, protect, store cardholder data. It should be stored unless it's necessary to meet the needs of business and sensitive data on a magnetic stripe. And more. Requirement 4, encrypt transmission of cardholder data across public networks. Don't do that, that's bad. And it continues, and I hate my life. This goes on for another 7 pages, and that's just the start. When you are PCI compliant, you have to be audited by an auditor who will come to your office and sit down with you personally for 3 to 4 days, 9 hours a day, and go through every single switch, router, line of code, and process that you have in the entire company to validate that you are PCI compliant. This is a tremendous amount of work. It is really complicated. So what would you do if you had to make your entire business PCI compliant? Basically, in my point of view, it's not. There's no way that you could make every laptop. There's no way that you could make every router. There's no way that you can make every Wi-Fi access point. There's no way that you can make every possible server that handles HR to be PCI compliant. So what do you do if you need to handle PAN numbers on a day-to-day basis? Suppose you're an analyst, you're a fraud analyst person who needs to see credit card numbers on their laptop. What do? You could use a tokenizer. And so what does a tokenizer do? Well, a tokenizer, it takes the credit card PAN and it turns it into a token, and you have success. But let's go into some more detail than that. Tokenizer will take the PAN from the incoming transactions and converts them into a one-way hash. It's a cryptographic hash that will be generated the same number, the same hash is generated from the same PAN each time, but it cannot be turned back into a PAN number. It's a one-way encryption. And the tokenizer is a system of services and containers that we installed in Amazon AWS. And AWS was chosen because it was already documented to be highly PCI compliant. Now, this was not the case with every other cloud provider that we looked at. We looked at Google. We looked at some of the other competitors out there that handle cloud services. And the level of documentation that they had for PCI was something along the line of, we are PCI compliant. And that was about it. There was not a lot of detail. There was not a lot of explanation about why it is that they're PCI compliant, whereas Amazon had layers and layers of documentation that we could prove very conclusively exactly how it was that they maintained compliance. Prior to this, the company had been entirely based upon co-location physical servers. We had rack-mounted lease servers running Zen server. We had entirely a virtualized environment. Everything we had was in 2 different data centers co-located. All of our R&D, all of our research, all of our analytics, all of our AI development tools running on physical servers. This was the first expedition we had into the cloud. And this was because we needed to become PCI compliant. So what's a closer look at a token? Well, you can see that the first number here, where it says the first digits of the PAN, this is actually allowed. And actually, the last digits of the PAN are allowed. It's the piece in the middle that is not allowed to be visible. And this is the hash segment. So when we have an analyst who looks at a transaction or a pattern of transactions and says, to me, this looks like a person was doing something suspicious, and we'd like to build this into our rules engine, we can look at this token and say, we have seen this token before. This token has been processed before. This person used this PAN at some point in the past in some location, and now we know where it is. But we don't need to see the actual credit card number itself, which means that that person does not need to be PCI compliant. This is the reason for the tokenizer. So what is the components of this? Well, in broad terms, we have, does this point actually? I don't think it points. Anyway, we have the transactions that come into the data center. We have what we call the PCI zone, which is a short term, a short of hand that we have to describe things that have to be PCI compliant. We have the tokenizer. We have an output from the token. We have 2 separate outputs from the tokenizer. One is delivered to an Amazon SQS queue and is saved to an Amazon RDS PostgreSQL database. Why do we save it to a database? Because we want those numbers to be reversible if we want them to be. So I mentioned before that they are cryptographically irreversible. So instead, what we do is we create a key value pair where the token is matched to its actual PAN number. And this PAN number is stored in a highly secured Amazon RDS PostgreSQL database. And I'll get to it in a second, but I can tell you right now that the only way you have access to this database is with this YubiKey. I have a YubiKey in my pocket. There are 3 more like it that my staff has. You must use this key to gain access to the jump host. Otherwise, you have no access whatsoever to the Amazon RDS PostgreSQL database where the PAN numbers live. This is an overview of the components. To the left, we see there's a jump host. I mentioned I've got the YubiKey. We've got OSSec client, which is an intrusion detection system. We've got CloudWatch agent. We've got a number of ports that are open to the management system. Again, OSSec SMTP, because OSSec needs to send us emails. We've got the CloudWatch agent. We've got the monitoring squid proxy, which sends all of our Prometheus statistics to our main servers back in the data centers. And then we have the tokenizer itself. Again, OSSec, the tokenizer container, Nginx for forwarding, the auth service to make sure that people are allowed to be sending us this information, the CDV storage, which goes to the PostgreSQL database, and again, the CloudWatch agent. You can see that there's an awful lot of arrows. There's especially a lot of arrows that are facing the wrong direction. These are all arrows where it says to the cloud on the left here. These are inputs that are required to comply with PCI. For example, you need to have an antivirus program. PCI requires this. How do you get antivirus updates when your tokenizer, by the law, by the rule, is not allowed to actually contact the internet directly? Well, you have to do it through proxies. This is what this management server does. The yellow management server in the center handles proxying information in and out of the tokenizer to handle things like OS patches. It handles things like antivirus updates. It handles things like alerts. It handles things like intrusion detection. This, in my opinion, is not optimal. In my opinion, there are too many arrows that are attached to the internet. I think it's ironic that we have to have so many contacts to the internet in order to maintain compliance. We are almost as if we are opening holes in the system to prove that we are compliant in attacking and increasing our attack surface. And I'll get to this in a second about why it is that I think that this system could be improved and what our plans are for the future. Yeah, so there's some drawbacks to this design. The PCI rules require too many layers of proxies and indirectly connected services, and this requires a lot of complex and possible fragile designs. You can see there's a lot of arrows between the services themselves. There are SSH ports, there are OSSec ports. All of these services have to be talking to each other. If any one of them stops talking to each other, we have a problem with the PCI zone. And since this is the main ingress for all of our customer data that comes to us, if this has a problem, that means that we are no longer receiving information from our customers, and this registers as a network outage on our part. So also, it's difficult to automate. It's partially automated at this point. We can deploy most of it with Ansible and Terraform in AWS. It's difficult to scale if we need more than one of these things running, which we actually do, or if we want to have another one that's in a different availability zone or data center, it's difficult to reproduce. And it requires things like antivirus programs, which are obsolete and add a lot of overhead. And considering that my mom is not running Windows Millennium on this server and opening email attachments, antiviruses are not the most frequently used attack vector to get into the system. So what is our plan for the tokenizer in the future? GitLab. We use GitLab pipelines for almost everything that we do in our development cycle. If you're not familiar with GitLab pipelines, it's very similar to Jenkins pipelines. You have a system, a series of steps that take place in a sequence, and those build steps can either be used to integrate code or deploy to your environment. What we would like to do is move this system out of our system of instances running on Amazon into ECS. And in the previous, you can see that we have in the tokenizer, each one of these boxes represents a container. Each one of these containers could be running in ECS instead. But how do we prove to the auditor that the containers that are running in ECS are actually PCI compliant? So the idea is to build a pipeline that will do all of the things that we're currently doing live in the PCI environment ahead of time. So for example, We could patch the container OS. We could run the antivirus scan. We could patch and update the code. And we can push the whole thing to ECS. And this would be done in this GitLab pipeline. And we could be doing this perhaps once a week, maybe even once a day. This means that we're no longer running updates on a live running system with all of the fragility and instability that that entails. We're going to be replacing a live system with an immutable object that gets replaced rather than trying to update it live. So what does this have to do with anything else? The greater part of the story here is that we were not really enthusiastic about going to the cloud as a company at first. One of our main selling points to our customers is that we handle all of your own data ourselves. We do not transit through any other companies that you might consider to be a competitor if you are an online merchant. And if you're an online merchant, one of your principal competitors is obviously going to be Amazon.com. And so there was some hesitance on the part of the company to invest in cloud technology, knowing that we would no longer be able to tell potential customers that we handle all of your data, all of your precious credit card data in-house. But with PCI compliance, we basically had to be more flexible. And our physical data centers did not look like this. We used co-location sites where I'm pretty sure that we had desktop computers running on tables, and the performance that we had was very, very startup-centric. It was, in my opinion, something of a toy. But now moving to Amazon, we actually have something more of an enterprise quality system. And how did I make this case? As the operations director for the company, how do I go to my boss and say, look, I know that you distrust the cloud. I know that your customers potentially don't like the idea of having your data handled by a competitor company. Well, the main issue is that we were growing. The main issue is that the company was adding customers. And as we're adding customers, the growth of our complexity was growing at a much greater rate than the growth of the business. And here's an example of some of the data that I showed my management to describe this with actual numbers. We have, on the average, 100 new terabytes of data every 6 months. This will increase. If we want 100 terabytes of replicated storage, we need 6 terabyte disks times 16 times 3, which equals 50 disks total. And these were physical disks that we had to call and buy and order and have them install and format and install ourselves, and then monitor and then RAID. This was a tremendous amount of overhead. If we wanted 500 terabytes of storage, naturally, we need 256 disks total. Each one of these things is a bomb waiting to go off. It is going to fail. It's going to fail in the middle of the night. If we have to do this with our production systems, we're going to have to deal with outages, and we're going to have to hire a lot more people. Right now, we have 4 people in our operations department. If we had to maintain data centers at the rate at which we were growing, we would need to be adding a new person. I calculated almost 6 months. Every 6 months, we'd have to hire a new person. So the cost of adding an employee, when compared to the cost, the marginal cost of moving to the cloud, and all of this rather drastic increase in complexity, it became a fairly straightforward calculation to say, look, it's going to be much, much cheaper and much, much more sustainable and much, much more scalable if we move away from our physical data centers and accept that some of our customers might not be happy about operating in the cloud. But in the end, it was our need for compliance that propelled our move, and the performance of the environment that sealed the deal. And without PCI compliance, driving the need to innovate, we probably would not have made this leap, or at least it would have been significantly delayed. So in this case, even though PCI was this rather large headache that we had to deal with over the course of almost a year, to become compliant, it was, in my opinion, greatly beneficial to the company because it moved us from a startup mentality where we had everything held together with Band-Aids and duct tape to an enterprise quality company where we can now scale, where we can now use the latest technology, where we can now automate. And this brings it to really my next point here of the future and what this means not just to the company but to myself and to my team. This means that we can actually move from DevOps to DevOps. And I've made the tiny little dev over there on the left-hand side small because when we were dealing with physical data centers, all we did was maintenance. All we did was operate as systems administrators. All we did was fix things when they broke. All we did was chase things around and stick our fingers in the dike to stop the water from coming through and flooding the system. Now we can actually move into a situation where we are more like operational developers. And we can automate, we can write code, we can spend our day doing things that we find more interesting, more productive, and a better use, frankly, of the customer's money and time, when the customer being, in this case, the business and the analytics team. So freed from the toil of maintaining hardware, we can now turn our focus to delivering automated solutions to the company. We're working on the creation of a self-service API. This would allow internal users to request and provision infrastructure according to company policies without trouble tickets. This means that my team, the operations team, is going to transition to a platform team. This means that we're going to be providing self-service turnkey solutions to analysts and developers without having to wait for us to do things. They can simply put in a request, press a button, the system is deployed, they have the resources they need, it gets checked against our budget to make sure that we can afford it, it's deployed automatically, and they don't need to wait for us to do it. And this will, I believe, turn something that might take a week or more for us to get to it, put it into our trouble ticket system, respond to the problem, allocate time to it, provide the solution. We can take that from a week down to minutes. Or seconds, potentially, because we're now moving away from this kind of restrictive hardware model over to a cloud model. We're going to be cloud agnostic, and as much as we love Amazon, we may have customers potentially in Asia in the future who would like to use their own cloud-based systems, maybe something like Ali Cloud, maybe something internal. This means that we do quite a bit of our own development work on our team to maintain systems that are not fully burrowed into the Amazon infrastructure or ecosystem. So a good example, EKS. We did a lot of debating about EKS because we run all of our systems on Kubernetes. Kubernetes is our plan to be is our universal platform. The goal is to have every single thing that we have running in the company, databases, Kafka, everything on Kubernetes by the end of the year. This means that we can deploy anywhere where Kubernetes is running. We can easily deploy using all of our code, all of our automation, the same way, the same time, the same method everywhere, right? So cloud agnostic. This means that things like EKS, we'd elected to not go with that because this would mean that we have something of a dependency with Amazon. We need to have our masters are going to be maintained by the company. We wanted to make sure that our masters in the Kube clusters are being maintained by us, and that we have that automation code to control them and deploy them. This was a decision that we made. This adds quite a bit of overhead. This adds quite a bit more development work. But we believe in the long term, it's in our interest to do this because we have more flexibility. We'll be able to deploy on any cloud or potentially on virtualized systems anywhere in the world in the future. User management, security, monitoring, logging, and budget controls, these will all be part of this self-service system that we're hoping to create. This means that if you put in a request for a new S3 bucket, we validate whether or not you have permission to create an S3 bucket. We validate whether or not you have the budget to create an S3 bucket. We validate who has access to write to the S3 bucket. And this is all done automatically at the moment that they put in the request. We'd like to integrate our development efforts with Fraugster's Golang development pipelines and procedures. We write all of our code in Go. We write all of our Fraugster AI, the Frog engine, the rule sets, everything is written in Go by our developers. We, in our operations team, we've been writing things in Python, we've been writing things in Bash, we've been writing things in some other languages. What we would like to do is actually integrate our team into the developer team. We would want to be considered first-class citizens within the company. We don't want to be called the operations team anymore. We don't want people to refer to us as systems administrators anymore. We want to be developers. We want to be first-class citizens. So this means that all of our automation code, all of the code that we use to write our applications, our self-service applications, will be written in Go, and it will go through the exact same development pipeline that our developers use. This means linting. This means merge requests. This means all of our code validation. This means unit and smoke testing. We're going to completely buy into the system that has been developed by our developers and treat ourselves with the same rules and the same regulations, with the idea of promoting quality of service the same way that they do. And I think that this is a really important step for us, because this means that we are actually doing what DevOps is intended to do, which is separate the distance between the operational people and the developers. And at first, our team was called the DevOps team. I had to change that. There is no such thing as a DevOps team. A DevOps is a philosophy, and I believe that by moving in this direction, we actually will be able to kind of close the circle and fulfill the vision of what DevOps actually is. And going to cloud was a huge part of that for us. So there you go, why it is that PCI compliance really actually completely changed the way that we do business, and really revolutionized how it is that we will be operating within our company. Any questions? Yep. In PCI, sure. So this is a question that comes up a lot, because PCI requires that a person who has access to one part of the PCI zone should not be accessing other parts of the PCI zone. We do have this to a certain degree, but if you read very carefully the way PCI works, it doesn't mean that you can't collaborate. It just means that one person is responsible for example, handling updates. Another person is responsible for accessing the database. We can still do this, and we can still hand these rules out to different people, but the process itself can still be integrated, and we can still have different people who are responsible for different roles within the system. Well, it's a bit of a gray area there, because when they say delegation of duties, what they mean is that they don't want one person who has basically root access, right? They don't want one person who's the overlord who can do everything. In practice, what this really means is that you make an agreement, that you tell your auditor that we have agreed to separate duties to different people. This doesn't mean that there's literally no way that one person can get access to it. That is simply not a realistic proposal. There's no way that you can make it that, it's not like a nuclear attack where you have to turn two keys at the same time and have two different people do it. It's more like that you have an organizational delegation of responsibility. And if you can prove that you've done that, then you've generally satisfied the requirement of the PCI auditor. Nope. Am I not collecting personal data from what? We collect all sorts of personal data. Yeah. So we're also fully GDPR compliant as well. GDPR is far less stringent than PCI. In fact, if you are PCI compliant, you're almost by definition GDPR because you've done all those things plus more. But we also are GDPR as well, which is a whole other. GDPR does cover things like laptops. For example, my laptop has an encrypted disk. Everyone's laptop has to have encrypted disks. We have to have two-factor authentication throughout the organization. There's a lot of things for GDPR that we have to be compliant with also, but that was a bit beyond the scope of what we're talking about here with our cloud migration. Yep. That's a really good question. I don't think we've actually solved this yet. We may have to have our build pipeline be in the PCI zone itself. This is a possibility. We'd have to isolate it. This is obviously what I mentioned there is very much like a prototype. If we have, and again, when you're working with a PCI auditor, it's there is no set rules about how you do things. It's more like you go to your auditor and you say, how would I do X, Y, Z? And they look at you and like they say, I don't know. I don't know how you do X, Y, Z. But they point to rule number 6 and say, does this satisfy rule number 6? And then you have to say, OK, I will explain to you why my idea that I have satisfies rule number 6. And if you convince him, then you pass. So PCI does not have an architecture that you can just start to use. There is no pre-made solution. So if I can prove to him that my CI environment is only accessible to people with a YubiKey, and it is no part of that is actually going to be touching the PAN data itself, then I may not even need to have the CI/CD part of it included in the PCI scope. If I can make it so that it's isolated from it, then I don't need to prove to the auditor that the CI building part of it is actually in the PCI scope. But again, I don't know. This is something that you have to go. It's almost like you have to invent it and show it to them, and they'll say yes or no, this will work. And you iterate, and you go. This is why it took a year. It took a year of coming up with the system that we had. And if you want to innovate, you want to change, you want to try something else, you pay them for their time, you pay them for their consulting hours, and then you show it to them, and they say, yes, I agree that this works. And so maybe we keep CI entirely out of scope in some other way that we haven't thought of yet, but it's a good point. We will have to worry about that. Yep. Yeah, so the PCI rules were probably written about 10 years ago, and they were written at a time when most people still used physical data centers. And a lot of the rules do things like reference how you need to set up your firewall rules, and how it is that there's requirements that there have to be physical locks on all of your racks. There's requirements that there has to be monitoring in your data centers. That's the part for us that Amazon handled, because they just do that already. If you were a larger company and you had your own data centers, you would have to do all that. I could see an example would be when I worked at VMware. We had a federal team that handled work with the US federal government. And they actually worked in a separate room that was not connected to anything else. It had its own network, and you were not allowed to bring like cell phones or devices into this room. This was like the federal zone. And I could imagine that if you had to be fully PCI compliant in a larger company, you might have to have some kind of isolated environment like that, because the rules are just that strict. Trying to bring in your own devices, your own laptop that you bring home in your car, that just simply would not wash. You'd have to have something much more restrictive. All right, thanks.